Welcome to the deep dive. Ever stop to think about how your cereal box or maybe a milk carton gets designed?
Probably not something most people ponder over breakfast.
Right. But today we're diving into something quite interesting. The surprising role of mathematics in all this.
Specifically, differentiation and integration, which, might sound a bit intimidating at first.
Exactly. We're looking at how these concepts fit into food packaging within food science. You're here to get smart, fast. So we've sifted through material connecting these, well, somewhat abstract math ideas to real-world packaging.
Mm-hmm. Stuff aimed at college students, bridging that gap.
Yeah. So our mission today, to really unpack how these mathematical tools are, fundamentally shaping the food packaging we see every day, making it effective, innovative.
It really is amazing how these core concepts pop up in everyday objects.
Yeah.
So let's start with differentiation.
Okay.
Think about driving. When you brake, differentiation helps us understand the rate your car slows down, how quickly that speed changes.
Right, the rate. Gotcha.
Now, let's apply that to, say, a food package. Differentiation helps figure out how quickly the temperature inside might change.
Okay, so knowing that rate of change, the derivative you called it, how fast the temperature shifts.
Precisely.
That means engineers can use that info to, design better materials, like make packaging that keeps things cold longer.
Exactly.
Yeah.
Imagine they figure out the rate allows, I don't know, a 10% slowdown in temperature change per hour with a new material.
Wow, okay.
That means your frozen peas stay frozen longer.
Ah,
That's differentiation, directly preventing spoilage, making a real difference.
that makes sense. So that's the how fast part.
Right.
What about integration?
Right. So integration.
Yeah.
Think about filling a bathtub. Integration helps you calculate the total amount of water needed to fill it right up, the accumulated total.
Ah, okay. Total amount.
Yeah. So in packaging, integration is like super important for calculating the total volume a container can hold, or the total surface area, which tells you how much material you actually need to make the container.
Okay, so differentiation is the how fast of change. Integration is the how much total, like calculating exactly how much cardboard for a box to minimize waste. Is that it?
You got it. Minimizing waste, minimizing cost, it's all connected.
So how does this math become, something tangible, something we can actually see?
Let's take a concrete example. Maybe a juice carton.
Okay, Gene Carton.
Using integration, engineers can calculate the exact volume it needs to hold. 1 liter, half a liter, whatever it says on the label.
Mhm.
They need to ensure that volume is accurate based on the carton's dimensions.
Makes sense. You want the juice you paid for.
Right. Now, let's say they want to optimize the shape. Maybe make it easier to grip, but still hold the same amount of juice.
Uh-huh.
That's where differentiation might come back in. They could analyze how small changes to the carton's width, for instance, affect the surface area,
Ah, the surface area.
which connects back to the amount of material needed. Exactly. So they're balancing usability, volume, and material cost, using both integration for the volume and differentiation to optimize the shape versus material use.
That's a really clear example. And the source material we looked at, Integration in Food Science Volume of Food Packaging Design, it really hammers this home, doesn't it?
It does. It emphasizes that these aren't just abstract equations learned in a math class. They are fundamental tools.
Practical tools.
Practical tools used daily to make packaging efficient, safe, even innovative. You realize basic calculus is really providing this powerful framework for design.
It's kind of mind-blowing, actually. That math you maybe struggled with in school
Yeah, maybe.
is directly influencing the design of something you grab from the fridge every single day.
It is. And what's fascinating is how widespread this is,
Ah.
which, leads to a thought for you, the listener.
Oh.
Yeah, considering that even basic calculus underpins something as, everyday as food packaging.
Huh.
What other seemingly abstract subjects might have surprising, tangible applications all around us? Things we haven't even thought about.
That's a great question. It really does make you think about how interconnected everything is. Like food science isn't just about, food chemistry. It involves physics, engineering, and calculus.
Absolutely. The interdisciplinary nature of it all.
Who knew calculus was playing such a key role in keeping our groceries fresh and contained? Thanks for walking us through the math behind the meals.
My pleasure. It's fascinating stuff.